7.4. First thing I want to make sure you understand is 7.4, basically, you already know how to do. Because we've talked about function notation. Excuse me. We've talked about function notation. And you know how to add polynomials, subtract polynomials, multiply polynomials, and then you've done a little bit when it comes to division of polynomials. So the biggest hurdle that you have to get over is that if you see anything written in the form that you see on the left-hand side, if you see it written as f plus g evaluated at x, f minus g evaluated at x, if you see them written right next to each other, that means multiplication, so f times g evaluated at x, and f divided by g evaluated at x, the first thing that I strongly suggest you do is that you rewrite it and you look at it as what it should be, which is the notation you're more comfortable with. So basically, when you see f plus g evaluated at x, all it's telling you to do is to take those two functions that they give you and add them together. If it's f minus g, you want to take those two functions and you want to subtract them. F times g, you want to take those two functions and you want to multiply them. F divided by g, you want to take those two functions and basically write them as a quotient or write them as division. Now, as you'll see with a couple examples, you can make some sign errors very easily if you don't pay attention to what you're doing. So we'll be real careful when we go through this. But again, you already know how to do this. I'm just basically doing it with two different functions. So let's look at a couple examples. But I'm going to rewrite everything that I ever see as the left-hand side. I'm going to rewrite it first and foremost is what you see on the right-hand side. That's the first thing we're going to do every single time. It's not given to us like that. And again, these problems work exactly the same way. You're going to be given a general formula, just like you were given back in 7.1. And to evaluate means that you want to replace all those x values with the value that they give you. And then you want to do whatever algebra or arithmetic you need to do to simplify. But the one thing I want to stress to you is that I'm not doing any kind of, I'm not distributing x. That is just notation that they use, kind of like the f of x notation. F of x didn't mean to multiply, and so here it doesn't mean that I'm multiplying or distributing that x. So be careful about that. All right, so let's look at how this works. So we have two functions. F of x is x squared minus 3x plus 5, and g of x is 16 minus x squared. And so what we want to do is we want to take those two functions, and letter A says we want to take those two functions and we want to add them, so f plus g, and you want to evaluate that at -1. So what I've given you on letter A is a specific number to plug in for x. But just like I would rewrite f plus g of x, I'm going to rewrite f plus g evaluated at -1 in the exact same way. What that means by definition is I'm going to take my function f at -1 plus my function g at -1. I'm going to take those two functions, and whatever I get for f of -1 and whatever I get for g of -1, I'm going to take those two values, I'm going to add them together. So we all know how to do f of -1. I'm going to do it to the side over here. F of -1 means I take my function f of x, and everywhere I see x, I replace it with -1. So this would be -1, that raised to the second power, minus 3 times -1, and then plus 5. So -1 squared would give me 1. -3 times -1 would give me positive 3, and then plus 5. So 1 plus 3 plus 5 would give me positive 9. So back over here, f of -1, I now know what value to plug in there for f of -1. F of -1, I can plug in positive 9. Plus g of -1, I'm going to do the same thing, I'm going to do it over here to the side. So g of -1 means I take my function g of x, which is 16 minus x squared, and everywhere I see x, I'm going to plug in -1. So it's going to be 16 minus -1, that quantity squared. Now again, you got to make sure you do your order of operations correctly. In order of operations, it says that we have to do exponents before we subtract. So g of -1. This is going to be 16. Do not make that minus a negative a positive because I can't do that yet until I do my exponents. If I take -1 and I square it, I get positive 1, so that stays as 16 minus 1 because -1 squared is positive 1. And 16 minus 1 we all know to be 15. So f at -1 was 9. G at -1 is 15. And then we all know what 9 plus 15 is. 9 plus 15 gives us 24. So it asked me to find f plus g of negative 1. I rewrote it using my definition, and then I just did what it said. We all know how to do f of negative 1 like we did back in 7.1. We all know how to do g of negative 1 like we did back in 7.1. And so f plus g evaluated at negative 1 is positive 24. All right, so second one there. F of 2 minus g of 2. That's already in the notation that we needed in. And so I'm just going to do it right here in the problem. I'm going to put some brackets around this. So f of 2, that would be 2 raised to the second power minus 3 times 2, and then plus 5. There's f at 2. Minus g at 2. G at 2 would be 16 minus, and then I have 2 raised to the second power. Sorry, I'm not getting there in my other problem a little bit. All right, so f of 2 minus g of 2. If I come in here, 2 squared is going to give me 4. So this is going to be 4. Negative 3 times 2 gives me negative 6. So 4 minus 6, and then plus 5. There's f of 2. Minus, then g of 2 would be 16 minus 2 squared, which would give me 4. So 16 minus 4. So f of 2. 2 squared minus 3 times 2 plus 5 would be 4 minus 6, which is negative 2. Plus 5 would give me 3. So this is 3 minus, and then 16 minus 4 I can simplify. 16 minus 4 is 12. And then 3 minus 12, I'm going to do it to this side over here. 3 minus 12 you all know to be negative 9. So f of 2 minus g of 2 is negative 9. All right, so again, sometimes they may give it to you in the notation that doesn't look familiar to you, like they did with letter A. But the first thing you want to do is just rewrite it as I did, and then do what it says to do. F of negative 1 plus g of negative 1. And then letter B, sometimes they may go ahead and just give it to you in the nice notation that you're used to. But make sure you watch the operation. If it says to add, make sure you add. If it says subtract, make sure you subtract. So be careful that you just watch your signs throughout the problem and watch what operation they're having you do. All right. Now, same two functions. F of x is x squared minus 3x plus 5, and g of x is 16 minus x squared. F divided by g of 0, if I use my notation, that is f of 0, that divided by g of 0, if I use my definition that we talked about back on the first slide, 7.4. And then I can come in here and I can find out what f of 0 is, and I can find out what g of 0 is. So f of 0, everywhere I see x and f of x, I'm going to replace it with 0. So this is going to be 0 raised to the second power minus 3 times 0, and then plus 5. And in my denominator, that's going to be 16 minus, and that's going to be 0 raised to the second power. So we can do this pretty quickly. 0 squared is 0, minus 3 times 0, which is 0, plus 5 just leaves me with 5. And 16 minus 0 squared, this is going to be 16 minus 0, which leaves me with 16. So f divided by g, that evaluated at 0 was 5/16. I can't do anything with 5/16. Can't reduce it. So there's my final answer there, is 5/16. All right, so again, just make sure you watch the operation and make sure you rewrite it using the definitions on the first page, and then it works just like it did back in 7.1. Pretty easy. Now, you notice letter D. It didn't give us a number to plug in for x. It just says take f times g and evaluate that at x. Well, if I use my definition, first of all, then f times g evaluated at x, that's just going to be f of x that I'm multiplying by g of x. Now, if I had a specific number to plug in for x, I would do that at this point, but it didn't give me a specific number. It just left it in terms of x. Well, if it leaves it in terms of x, all I can do is leave my answer for you in terms of x. So now, f of x. Look up here. We see what f of x is equal to. F of x is equal to x squared minus 3x plus 5. So I must substitute what f of x they define it to be. And they define it to be x squared minus 3x plus 5. So I substituted, so I'm putting parentheses around it, times, and then g of x, I also have a formula for g of x. G of x is 16 minus x squared. So, definition, f times g evaluated at x. So use the definition. That means f of x times g of x. And since I don't have a specific number to plug in for x, all I can do is write down what those two functions are. F of x was x squared minus 3x plus 5, and g of x was 16 minus x squared. Now you all know how to multiply polynomials. I've got to take a trinomial and multiply it by a binomial, so I'm going to have to distribute. I'm going to have to take 16 times all three of my numbers there, and then I'm going to have to take negative x squared times all three of my numbers there as well, and then I'm going to have to combine my like terms. All right, so let me just go ahead and rewrite that on a new slide because I don't have enough room down there at the bottom to do this. So x squared minus 3x plus 5. That times 16 minus x squared. So if I distribute 16 into all three of those numbers, or terms, sorry, that's going to be 16x squared. 16 times negative 3x, it's going to be negative 48x. And then 16 times 5 is going to be positive 80. And then if I turn around and distribute negative x squared into all three of those terms, then that's going to be negative x squared times x squared is going to be negative x to the fourth. Negative x squared times negative 3x, that's going to be a positive 3x to the third. Watch your signs, be careful. And then negative x squared times 5 is going to be negative 5x squared. So I multiplied the binomial times the trinomial, and I chose to take 16 times those three terms and negative x squared times those three terms. You could just have easily taken x squared times those two terms and negative 3x times the two terms and 5 times the two terms and gotten the same answer. All right, so if I write this in descending order, this is going to be negative x to the fourth. Nothing I can combine with negative x to the fourth. I got a positive 3x to the third. Nothing I can combine with 3x to the third. I have a positive 16x squared and a negative 5x squared. So I can write that as positive 11x to the second, or x squared. And then I have negative 48x that I can't combine anything with. And I have positive 80 that I can't combine with anything. So there is f of x times g of x. F times g evaluated at x is negative x to the fourth plus 3x to the third, and so on. So I'm just doing what it told me to do. It told me to multiply those two functions together, so I took those two functions and multiplied them together. And if I don't have a value to plug in for x, then my final answer has to be an expression just in terms of x. I just multiplied those two polynomials together. All right.